For the second part of our lesson, we are going to look at some more advanced problems. These problems were taken from the 2018 contest, along with one other one for a different contest. The first two are considered warm-ups, and you should be able to do these on your own. So pause the video and then come back and check your work. All right, so this first problem, we want to take a look at how to convert this into base 11. Now, when we look at how many digits we have in the number, 4 digits, we know that the leftmost digit is going to be 11 to the third power. So it's always the number of digits minus 1. So if we fill in underneath each digit the value of that power, so for example, this is 11 to the 0, 11 to the 1, 11 squared, and 11 to the third power, we can see how many of each of that place value go in that spot. So what I like to do when I'm doing conversions like this is ask myself, okay, well, how many times can 1331 go into 2018? And it can only go in one time. So I'm going to subtract that off, and that will give me 687. Since I was able to put that in one time, I'll put a 1 up here in the 1331 place value. Now for the next one, for my 121, I can fit that into there 5 times. So I'm going to subtract 5 times 121, or 605, and that will give me 82. Now I'm on to the 11s, and I can fit 7 11s, so 77, subtract that away, and I have a 5, and now I'm down to the ones place, so I have 5 ones. Remember, when we are in base 11, every value has to be between 0 and 10. So once we would get to an 11, we will go up to the next column over. And so my final answer is 1575, base 11. All right, now if we go on to this next problem, for this one, what I like to do is think about how 9 and 3 are related. So in some problems, if we have 2 different bases, it's easiest to go from the first base to base 10, and then from the base 10 into the second base. So like in this case, 9 to 10, 10 to 3. However, since 9 and 3 have a common relationship, we can say that we know 9 to the first is equal to 3 squared. So what we can do is we can expand this with base 9, and then we can replace all of the 9s with 3 squared. All right, so if we start with our expansion, we have 5 digits. So our leftmost value will be 9 to the 4th, so 1 less. So that would give me 5 times 9 to the 4th plus 8 times 9 cubed, 3, whoopsies, times 9 squared, and then plus 4. So I'm going to replace each of my 9s with a 3 squared. And so remember, when I take something that's a power and raise it to another power, I just multiply those powers. So this will become 5 times 3 to the 8th plus 8 times 3 to the 6th plus 3 times 3 to the 4th, and then still plus 4. And now, so essentially what we did here is this first part where I said expand with base 9, that's what I did right here. And then this next part when I said replace all the 9s with 3 squared, that is what I did here. So at this point now, I just have to go ahead and rephrase this so that it is in proper base 3 form. And in proper base 3, everything needs to be a coefficient times a power of 3. So all of these values that I see here, this 5, the 8, the 4, all of those are not going to work for me because they don't work in a base 3 number system. So I'm going to go ahead and I'm going to fix that. I'm going to have this 5, and I'm going to think of it as 3 plus 2 times 3 to the 8th. And then this 8, I'm going to think of that as 2 times 3 plus 2. Again, I'm trying to express this as a number times a power of 3 plus a number such that any of those coefficients are less than 3. And then this next one here can just stay the same. So 3 times 3 to the 4th. And then this one here will be plus 3 plus 1. Okay, so now I can simplify and distribute this. And I will have 3 to the 9th. So 1 times 3 to the 9th when I distribute that. Plus 2 times 3 to the 8th. Plus, oh shoot, over here I forgot to write in this 3 to the 6th power when I expanded that. Sorry about that. Okay, so now when I distribute this, that's going to become 2 times 3 to the 7th plus 2 times 3/6 plus this just turns into 1 times 3 to the 5th plus 3 to the 1st plus 1 times 3 to the 0th. All right, so now I have to write down all my place values. And when we're writing down all of our place values, remember the easiest way to know that is however many digits I have, the greatest value is that number of digits minus 1. So since this has a 9th power, I need to do 9 plus 1, which gives me 10 digits in my final answer. 5, 6, 7, 8, 9, 10. And so now I just go through and strip off all those coefficients. So 1, 2, 2, 2, 1. So those are my 9th, 8th, 7th, 6th, and 5th powers. And then 0 for the 4th, 0 for the 3rd, 0 squared. We had 1 for the 3rd, 3 to the 1st, and 1 for 3 to the 0. So my final answer is 1, 2, 2, 2, 1, 0, 0, 0, 1, 1, base 3. All right, that was fun. So looking at this next problem, we have 3 digits, A, B, and C. And we are told that they are non-negative integers that are less than 6. So when we see non-negative, non-negative means that it could be 0 and it's definitely positive. That's essentially what non-negative means. And the reason why we are told that it is less than 6 is because we need to think of digits that would work when we are in base 6, okay? So what I'm going to do is I'm going to recognize here that 41 is base 10, and I'm trying to figure out the possible values for A, B, and C, the smallest possible sum that would make this equation true. So I'm going to first start by going ahead and expanding out my base 7 and base 6. So a really common strategy in problems like this is to expand into your base 10. And that will essentially like level the playing field, you could think of it. Right now I have base 7, base 6, and base 10, but if I put everything into base 10, now I'm thinking in a consistent base. Now, when I'm looking at base 7, remember my leftmost digit is going to be, since there's 3 places here, 7 squared, or 49. So when I write this out, I'm going to say that I have 49 times A, plus I have 7 times B, plus I have C. Now you might say, oh, but isn't that really A times 7 squared and B times 7 and C? Well, yes, it is. So let's just simplify it by writing the coefficient first. And then now I have minus. Now I'm subtracting this whole quantity. I want to put it in parentheses because the individual values are going to be added. So I'll have minus 36A plus 6B plus C, and that is equal to 41. So now everything is in base 10. So now I'm going to go ahead and I'm going to distribute this and combine like terms. So 49 minus 36 is going to give me 13A, 7 minus 6 is going to give me B, and then C minus C cancels, giving me 41. Okay, so at this point, I need to remember that A, B, and C have to be positive values that are less than 6, and I'm looking for the least possible sum. So in this case, since C is totally irrelevant, C can just be 0. So right now when I'm looking at my possible values for A, B, and C, C is going to be 0. So now I have to start thinking about, well, what values would make this equation true? Now, if I made A equal to 0, there's no way that I could have a value of B that would make this equation true and still be less than 6. So I know that 1 is not, or 0 is not an option. Same thing is true for 1. 13 plus B equals 41. No way. 2, 26 plus B equals 41. Nope, that wouldn't work either. So then we get to 3. And 3 is where we have a winner. So if I do 13 times 3, that'll give me 39. And then if I go ahead and solve, that means that B has to equal 2. And so my least possible sum, my A plus B plus C, will give me 5.